Welcome everyone to this video. We want to discuss some questions. Mm, let's start with this one only. Yep. Yes. So let us discuss question number 9. So this question has two mirrors, M1 and M2, and a lens kept uh, in between these two mirrors. So the radii of curvature of mirror 1 is 20. The radii of curvature of mirrors 2 is 24, and the focal length of the lens is 10 centimeter. Now an object is placed right in the middle of L and M2. As you can see in this figure, between the lens and the second mirror, we have placed an object. So it is placed at 10 centimeter distance. Um Eventually, an image is formed which coincides with the source itself, with S. So we have to find that what is the distance between mirror and the lens. The other mirror and the lens, that distance is to be found. So basically what we'll do is that we'll say okay, this ray of light, it went like this. It reflected, it refracted, it reflected again, and then it basically, what can I say? It went to the center of curvature of the lens, number 2 of the lens, and as it went to center of curvature, it will basically retrace its path. So that is the whole point. So if we are saying that the lens is seeing an object at this particular distance, if at the same distance the mirror forms the object from the lens, then it will form the image at that distance. Or wait a bit. So if the mirror M1, it reflected back the ray of light, then we could say that yes. So that would be possible if the lens forms the image at the pole of the mirror number 1, M1. If that happens, then it can basically bounce back the mirror. But with that, we would say that the answer would be simply independent. What happens when the ray of light goes to the to the pole of the mirror? If the ray of light goes to the pole of the mirror, it gets reflected at the same angle. So if this is the incident ray, this would be the reflected one. In the same way, if this is incident, it will get reflected like this. So clearly we can see that the object and the image, they are formed at the same position. So this is what we are aiming for. So let's see. Okay. So let us start the image formation. First, the object is placed at 10 centimeter. So it's it's a concave mirror. So we have object distance as -10 and focal length of mirror 2 is 12. So it would be some -12 as it is a concave mirror. So we can say 1 upon V is equal to 1 upon 10 minus 1 upon 12. So 66 minus 5. So the image is formed at 60 centimeter from the mirror. So the image's distance from the lens would be 80 centimeter. So then we would apply lens formula 1 upon V upon it is formed at 80 centimeter. The object is at focal length of the lens is 10. So it is 10. So this implies 1 upon V is equal to 1 upon 10 minus 1 upon 80. So this is 88 minus. So it is 7 upon 80. This is where the image is formed. So that is where actually we want the hole of the mirror to be at 80 by 7 centimeter from the lens. So this distance n by 7 should be 80 by 7. So n should be equal to 80. So that's it. Thank you for joining.